Hello and welcome to another video by Berkshire Guitar Amplifier Repairs. Stuart Smith on the bench here in Reading, England, and we have today a Fender 68 Twin Reverb reissue. So this is a fairly modern amplifier. The customer says that the sound is distorted, and I have actually turned this amp on and had a listen, and there's an even distortion, a bit like a mild crunch sound across all volume settings, so it's not dependent on any of the volume settings. That immediately tells me it's probably in the output stage, and I'll be looking either for a dead valve or something of that matter similar to that. So I'm not going to do too much more to this. I'm going to get the chassis out and get it up on the bench, and we can start to investigate this. I don't think this one's going to take me too long. Okay, here we are top side. The customer had broken off the spigot, the little thing that sticks down, plastic bit, on one of his valves, so I've put a new pair of 6v6s in here just for the purposes of our test. It's all immaculate. This is not very old, of course, this amp. I've got the amp switched on and out of standby, and I've got one bias probe on this valve here, and here, if you can see that, this is the 426 plate volts and 27. This new Eurotube's LED meter is very hard to read via a camera. Anyway, we've got 27 milliamps, 428 plate volts, all looks fine really. So I've hooked it up to a dummy load here, and I've got the scope hanging across the dummy load, and I've got my signal generator here and a scope. So watch what happens when I wind it up. This is the output, of course, and you can see we've only got half. Only one valve is conducting. This should of course be nice and sine wavy. One valve is conducting, one valve isn't. Alright, well that's very interesting, because I just randomly selected this valve to put the bias probe on, and it all looks fine. Let's this is interesting. This valve is too hot to touch, which is kind of what I'd expect, and this valve is cool. So this valve is not pulling any current whatsoever. I know it's not the valves because I have put a new set in, so there's no point in swapping the valves. So there's something wrong with this position here, not the valve, the position. So what we need to do is to turn it upside down and see what's going on with this output tube. I'm hoping it's not the output transformer. Half of the winding is gone or something. So if we've got HT on pin 3 of this valve, then it won't be the output transformer. It's a bit skinny, that output transformer, don't you think? I don't know, maybe a little bit small. It's only 6v6s, but so it's probably a 30 watt amp. Anyway, let's turn it over and have a look underside. Right, here we are on the underside. It's immaculate, of course. It's brand new pretty much. Very difficult to work on these amps. If you wanted to service a pot, you'd have to remove every single pot and every nut and get this entire printed circuit board out somehow, if it'll joggle past this one, in order to get to the pots to service them. Complete madness. Anyway, let's not moan too much about amp design these days. The first thing I want to do, I've put a little dot by the faulty, in inverted commas, valve, so I think it was just pure blind luck that we put a meter on this one and not this one. Had we put the meter on this one, we would have seen it was pulling no current. But let's see what it's got on the plate. So the plate is pin 3, 1, 2, 3, so it's this blue wire on the good valve. Is it on? No, it's not on. Let's turn it on. Right, the amp's now on, and on the plate of this good valve we've got 420 volts. Look, have we got HT on this one? It's here. Yes, we have. Okay, well, we've got HT then. Alright, well, if we've got HT and the valve is not conducting anything, and either the grid's hard off, which would be hard to believe. Let's see, that's pin 5, 1, 2, 3, 4, 5. So here's the grid, minus 36 volts, which is about what I'd expect. Negative bias on the grid. Let's try that again. minus 36 volts, and on this one, this grid here, minus 36 volts. So it's not like we've got minus 100 volts on there turning the valve off. Well, there aren't many options. A screen resistor would be a good next port of call. Where are the screen resistors? Normally they're tacked across the valve bases. Let's have a look. The screen is pin 4. 1, 2, 3, 4. This orange wire goes along here, comes up to here. Okay, alright, I can see the problem straight away. Right, here are the two screen resistors, 470 ohms and 470 ohms, and this one is burned out. Let's see if I can show you. It's under this wiring a bit. I think I'll just take the camera off the overhead and show you that. Okay, there you go, R63 on the right look. R62 is good, and R63 is burned out. So this amp has popped a screen resistor, almost certainly due to a faulty valve. Did he break the spigot or something and then try to put the valve in? And of course, if you've got it oriented without the spigot, you don't know which way round it goes. Did you pop it in and turn the amp on and it blew a resistor? That's certainly a possibility, isn't it? Anyway, we'll pop a new one in there and this amp will come to life. Okay, I'm going to do a top side repair here, as to take this board out would be quite a lot of work. I don't want to do that, and it would also cost the customer a lot of money. I can't be too purist about these things because it's always the client's money, and a lot of my clients are, well, they're not poor of course, but they're not professional musicians making 10 grand a month or something. They're just amateurs with a little band or something, or maybe just playing at home. And if I go in and say that'll be £200 please to fix your Fender, they are not going to be very pleased. So I kind of do reasonably low priced repairs for people. I'm in a fortunate position if I don't kind of have to do this for a living or anything. If I had to do it for a living, then I'm afraid I'd have to charge a lot more. So we're just going to put a little hook in there like that. And a little bit awkward this, not terribly well placed. There, now if we can get that soldered on there. Okay, yeah, that's good. There. Perfectly good repair. It'll last as long as the amp lasts and save the customer 50 quid. That's what I call a result. So now let us turn the amp back on and see if the situation has improved. Okay, let's turn up the signal and see what we get. And there's a nice sine wave, look, with two halves, just what we want. Now what power is the amp putting out, just out of interest? It's squaring off at 1, 2, 3.5 divisions, and we're at 10 volts per division, so it's squaring off at 35 volts peak to peak. we'll do a quick calculation and see what that gives us in terms of power output. So 35 volts peak to peak, that's 35 volts there, which is 17.5 volts peak. To get the DC equivalent of this peak to peak sine wave of 35 volts, we need to multiply the peak by 0.707. So 17.5 times 0.707 equals 12.37. So the DC equivalent voltage of a 35 volt peak to peak sine wave is 12.4 volts. And our power is given by the formula V squared over R. This is V, so it's 12.4 squared over R, which is our 8 ohm speaker resistance, or in this case our load resistor. So here we go again, we've got 12.4 squared is 153 divided by 8 ohms is 19.2 watts. So it's about 20 watts this is putting out, this amp. I don't know if it's supposed to put out more or less than that. It's only got 6v6s, so maybe that's about right. Anyway, that's what it's doing, 20 watts. Right, let's put a speaker on it and a guitar through it, just to make sure it sounds okay. That's good. Let's try the vibrato channel. Can't hear any vibrato, but that's almost certainly because of a foot switch situation. Let me see if I can find the foot switch. He hasn't said there's any problem with the vibrato, so we don't need to worry too much. No, he hasn't bought the foot switch, but there's no problem with that as far as I know. I do want to just check the bias whilst we're here though. So we've got 420 plate volts and 26 milliamps. Right, let's have a look what that is supposed to be for a 6v6. I'm going to go on to the Weber bias calculator at www.tedweber.com. Okay, I couldn't get onto the site, I had to go onto my computer upstairs for some reason. Anyway, 20 milliamps is about right apparently, and this is 26. So we have a handy bias pot here, which is good. So you might not be able to see this, but I'm just going to turn this down anti-clockwise to a more reasonable 20 milliamps. Job done. I think we can put this one back in its case. Well, there you go, a fairly quick repair. I always like it when that happens, and we fairly quickly diagnosed that one half of the push-pull pair wasn't working, so it was either the valve or the HT to that valve, or in this case the screen resistor had popped. We don't know why the screen resistor went on this. It could just have been a faulty valve, and you know, who knows. So I've put a new pair in, and fingers crossed that this is all good to go. So hope you enjoyed that one and learned something from it. I'll catch you on the next video, and thanks as ever for watching.